Theorem of perpendicular axis. This theorem states that suppose this is a disk. Now we know that moment of inertia of the disk about this diameter, and about it and perpendicular to this, suppose this is another diameter. Now if moment of inertia about this diameter is say Ix, if moment of inertia of this disk about this diameter is Iy, these two axes are mutually perpendicular and on the plane of the disk, then moment of inertia of this disk about axis which is perpendicular to the plane of the disk, that is this axis, say Iz, will equal to the sum of moment of inertia about x axis, moment of inertia about y axis. So now we will prove this theorem that suppose this is a body and we are having two axes, say this is x axis, this is y axis, these two axes are mutually perpendicular and on the plane of this lamina, and this is a perpendicular axis which is perpendicular to the plane of the lamina and passing through the point of intersection of x and y axis. So this is Iz. Then we have to prove that Ix plus Iy, that is moment of inertia about x axis plus the moment of inertia about y axis, equal to moment of inertia about z axis. Now let us consider a point mass P. Say M is the point mass, say xy is the coordinate of this point mass. Xy means this horizontal distance is x and this perpendicular distance is y. So this is x, this is y. Now let us join this point with the origin, let it be R. Now in this triangle PO, this foot of the perpendicular M, POM, we find that this angle is 90 degree, PMO angle is 90 degree. So we can write R square equal to x square plus y square. Now let us multiply this equation, left hand side and right hand side, by R and by M, that is mass of this point mass, mr square equal to mx square plus my square. Let us take summation notation of both the sides. Now what is mr square? Mr square is summation of mr square, means the sum of moment of inertia of the all point masses about z axis. This is nothing but the Iz, moment of inertia of the lamina about z axis. Mx square is, this is moment of inertia of the lamina about sum of moment of inertia of all the point masses about x axis. So this is nothing but Ix. Similarly, x, no, x is, this is nothing but this x is the distance, this is distance from the perpendicular distance from y. So this particular term is Iy, moment of inertia about y axis. X is this distance, perpendicular distance, and Iy is, y is the distance of this point mass from x axis. So my square, sum of all the point masses about x axis. So this is equal to Ix. So we find that Iz is Ix plus Iy. This is the theorem of perpendicular axis. If we know the moment of inertia of a lamina about two mutually perpendicular axes laying on the plane of the lamina, then we have to sum it up to find the moment of inertia of a perpendicular axis which is intersecting these two mutually perpendicular axes and which is perpendicular to the plane of the lamina.